Welcome to the deep dive. Today, we're kind of changing altitude completely. We're stepping way off the usual path of, optimizing AI algorithms. Instead, we're taking a massive, 2 millennium detour right into the heart of philosophy, from the Presocratics onward. Yeah, we're looking at some really profound sources arguing that AI's road to genuine intelligence, it needs a philosophical base. So our mission today is to explore if philosophy really holds the key. Can it push AI beyond just, crunching data, beyond being a supercalculator, towards what these authors are calling meaning-aware intelligence? And this whole idea led them to coin a new term, Sophimatics.
It is a huge claim, isn't it? I mean, we usually think of AI progress just in terms of more power, more data. But these sources, they make us ask these two really big questions. First one, how can we actually build AI to integrate this deep, philosophical, context-rich knowledge? And second, maybe more importantly, does adding this knowledge actually bridge that gap? The gap between current data-driven models and, well, real understanding, genuine meaning.
Exactly. So this isn't just about tweaking code. It's like rethinking the foundations of artificial thought itself. It suggests the philosophy baked into the design is maybe just as critical as the data you feed it for training. Okay, let's unpack this. Starting with something genuinely surprising. When you think AI history, you probably jump straight to the last, decade or two? Deep learning breakthroughs. But these sources, they uncover this fascinating thread running all the way through. Philosophical ideas have actually been sort of guiding AI construction all along. It's not just tech history, it's like intellectual history being translated into code.
And what's really striking is how specific these connections are. You can literally map core philosophical concepts going way back directly onto the different AI paradigms we've seen over the years.
Okay, let's go way back then. How does someone like Heraclitus, ancient Greek guy, how does that connect to a modern AI?
Well, take Heraclitus. His big idea was Pantarei, everything flows, right? Change is the only constant. That fundamental belief in constant flux, continuous transformation, that's basically baked into how we design intelligent learning systems now. If the world keeps changing, the data keeps changing, the AI itself has to be built to adapt. It sort of acknowledges we can never fully map out everything an AI learns in a messy world, only that it must learn to cope with change itself.
Okay, that makes sense for, adaptive systems today. But what about something more fixed, like logic?
That brings us straight to Aristotle.
Yeah.
His whole framework of formal logic, syllogisms, expressing universal verifiable truths. That became the literal bedrock for early symbolic AI. It led to the physical symbol system hypothesis back in the, 70s, 80s? The idea that intelligence simply is manipulating physical symbols according to clear rules.
So early AI was basically trying to build Aristotle's logic machine out of silicon.
Pretty much, yeah. Now, fast forward to the Enlightenment. You get Kant. He argued we have these innate structures of understanding, like built-in mental frameworks, a priori knowledge, that organize how we experience the world.
Yeah.
And that idea, it directly mirrors a key principle in modern AI. Think about how certain network architectures, like transformers maybe, they have an innate structure. They're pre-trained or designed with a fundamental organization before they even see specific data. Then they learn empirically on top of that. The architecture is the innate structure.
Okay, wait, I have to push back a tiny bit on Hegel. I mean, he's known for these really high-level, sometimes kind of obscure concepts like the dialectical process.
Yeah.
How does a 19th century idealist connect to deep learning? Isn't that just stretching an analogy, maybe?
Well, the sources argue it's more than just analogy. Hegel's dialectic, abstract ideas transforming into concrete reality, thesis, antithesis, synthesis. You can see a parallel in how, say, symbolic AI or even knowledge graphs interact with the real world. They constantly refine abstract rules based on actual outcomes. But maybe more crucially, it's his ideas around hermeneutics, the theory of interpretation, understanding context. That's vital. It helps learning systems interpret rules and concepts that change depending on the context. It bridges fixed symbols and the messy, changing real world.
That's actually a really powerful point. It shows philosophy wasn't just a historical footnote. It actually shaped the tools we built. But, okay, if that's true, why are we even having this conversation? If philosophy guided the construction, why do current AI models still seem to fall short of actual, meaning-aware intelligence?
And that brings us right to what the sources call the data versus meaning dilemma. The limitations really stem from the built-in constraints of those two big paradigms we just touched on.
Okay, let's revisit symbolic AI, the early rule-based stuff. The pro, as you said, was clarity. You could see how it reasoned. It was verifiable.
Right. But the huge downside was rigidity, wasn't it?
Yeah.
Those formal systems, they broke when they hit the real world's complexity. They couldn't handle ambiguous information, richness, constant change. They had that famous knowledge acquisition bottleneck. You just couldn't code in all the common sense needed. They were too brittle.
And that brittleness, that failure really paved the way for connectionist AI, right? The deep networks we have now, they kind of solve the flexibility problem. They learn from experience, from massive amounts of data, changing their internal structure. It's pattern recognition on steroids.
Exactly. And here's the modern challenge, the core problem.
Yeah.
These connectionist models, incredibly powerful, yes, but their internal representations are sub-symbolic. Think of them as just these vast, opaque matrices of numbers. They are fundamentally meaningless to the system itself. It can spot the pattern for cat incredibly well or learn patterns that lead to a truthful founding answer, but it can't possess intentionality. It doesn't have a true representation of catness or truth.
So the system knows what patterns work. It can mimic language amazingly well, but it has no idea why they work or if they actually connect to reality.
This sounds like exactly why we get AI hallucinations, right? The model just confidently makes stuff up because the pattern fits, even if it's nonsense.
Precisely. And that inherent meaninglessness leads directly to the big theoretical roadblock for current AI, the symbol grounding problem. If the system's internal symbols, the patterns don't actually connect to shared external human meaning for the system itself, it can only ever simulate understanding. It can't truly grasp things like intention, context, or even truth in a meaningful way. Wow. That's the fundamental hurdle then. How do you get real-world meaning into an internal pattern matcher? If we can't crack the symbol grounding problem, we're kind of stuck with sophisticated mimics, not thinkers.
Absolutely, and this is exactly where our source material shifts gears. It stops just pointing out the problems and starts proposing a way forward. The argument is that the only way past these inherent limitations is to develop a new class of systems, hybrid cognitive architectures. And this is where it gets really interesting.
Okay, hybrid. So mixing the old rule-based stuff with the new pattern matching networks, what do these architectures actually look like? What's the benefit?
The key benefit is they gain the ability to actually operationalize meaning. They combine the interpretability, the conceptual clarity of symbolic reasoning, that sort of Aristotelian clarity we talked about, with the raw learning power, the adaptability of connectionist networks, the Heraclitean adaptation. And this combination is just crucial. It lets the systems handle both clear rules and statistical uncertainty at the same time. What that unlocks in practice is pretty amazing. Hybrid systems can develop better mechanisms for long and short-term memory. They can allow for self-organized restructuring of what they've learned, and they get much better at reasoning about context because they can link those meaningless subsymbols back to explicit human understandable concepts.
So it's not just a clever engineering trick, it's more like an epistemological requirement, driven by the fact that neither approach works fully on its own. You need both ways of knowing rules and patterns to get closer to actual intelligence.
They're seen as necessary, yeah, because they seem to be the only type of AI system that can actually handle dynamic, context-heavy, really user-focused situations effectively. It's presented as the only currently viable path to bridge the gap between raw data and, genuine grounded meaning.
Okay, so we have a potential technical path forward with hybrids, but now we need to pivot slightly, right? Away from just the architecture and towards the necessary philosophical framework. Because even the most elegant hybrid system isn't enough on its own for true intelligence. Our sources argue pretty strongly that the next critical step is deep philosophical and ethical thinking applied right during development.
That's exactly right. If the goal is meaning-aware AI, then the design itself has to embody an explicit philosophy of meaning. The kind of ethical approach needed has to be pluralistic, inclusive, and deeply context-aware. We have to build systems that can actually recognize the value of subjectivity, of meaning, of individual experience, alongside just concrete facts or data points.
But why is that philosophical grounding so vital for the ethics part? Can't we just, program in some ethical rules, like Asimov's laws, but more sophisticated?
Well, the sources suggest that just hard-coding ethical rules runs into the exact same brittleness problem that killed early symbolic AI. Rules are static. The world isn't. If a system is ungrounded, if it doesn't genuinely grasp the meaning and the context behind its data and its decisions, its actions can end up being ethically catastrophic, even if unintentional. Think about, say, a hiring AI. If it just learns historical bias patterns from data without any mechanism to understand the meaning of fairness or the context of discrimination, it'll just optimize the bias. And that leads to really severe real-world harm for actual people.
Okay. So the philosophical grounding provides the essential context for ethical judgment. It's not just about following rules, but understanding why.
Precisely. And that points to the really actionable step highlighted in the sources, the need for participatory design. We need genuine engagement with ethical philosophy, not as an afterthought, but right from the start of development. This isn't just ticking a compliance box. It's seen as a necessary input to guard against systems being opaque or taking things out of context or just perpetuating biases hidden in the data. It informs responsible AI governance.
This really sounds like the ultimate interdisciplinary challenge, bringing philosophy, ethics, computer science, maybe even social science all together. And this seems to be where the work we're reviewing makes its unique contribution, methodologically speaking.
Yes, exactly. The big achievement claimed by this research is what they call a philosophical sin work. It's a synthesis, right? It explicitly integrates the philosophical foundations needed for meaning-aware AI ideas like context, intentionality, ethics, directly with the technical solutions like these hybrid architectures.
Can you unpack that a bit? What does sin work mean in practice? How is it different from just having, say, an ethics committee review an algorithm after it's built?
Well, a lot of previous work looked at these things separately. You'd have papers on ethical risks over here, technical papers on deep learning problems over there, maybe some philosophy papers on meaning somewhere else. The SynWork approach insists that the philosophical requirements, what does it mean for the AI to understand context or have intention? These questions have to actually drive the architectural design choices from the beginning. So philosophy becomes a core part of the methodology, not just a final check. It's seen as the path towards this idea of sophimatics.
But the sources are also pretty upfront about the challenges that still exist, aren't they? This isn't claiming mission accomplished.
Oh, absolutely not. They're quite clear. While this conceptual roadmap, this SynWork idea is powerful, some really tough problems are still very much unsolved. We still struggle with the black box nature of deep networks. We often can't fully explain their reasoning. We haven't completely solved the symbol grounding problem, even if hybrid systems offer a promising direction. And crucially, bias in the enormous, often uncontextualized data sets we use, that remains a massive, persistent issue. This is definitely presented as a roadmap, not the final destination.
Which brings us right back to that core conclusion. Genuine AI intelligence seems to demand a philosophical foundation to actually deliver meaning and context, not just more optimized pattern matching. Without that philosophical grounding, maybe we're just building incredibly sophisticated parrots, not partners in thought. So what does this all mean for you listening to this, maybe tracking AI developments? This research, even though it's conceptual right now, it points very clearly towards some immediate next steps for researchers, developers, policymakers.
Yeah, first off, the theory needs to meet reality. Future research has got to focus on actually implementing and testing these hybrid AI architectures, and specifically testing them in high-stakes areas where ethical understanding really matters. Think about medical diagnosis or legal reasoning systems.
Second, we desperately need real deep interdisciplinary work. It's not enough to just talk about context abstractly. We need practical methods to actually operationalize concepts like context, intentionality, maybe even ethics within these implemented systems so we can measure if they're actually working as intended. And finally, governance is key. We need to seriously investigate and roll out participatory methods in AI policymaking. We need to make sure that the development of transparent, ideally meaning-aware AI actually reflects broad human values, not just what's technically possible or profitable.
And that leads us to one final, perhaps provocative thought for you to take away and chew on. Given that the real effects of adopting a particular philosophical stance and the design choices that follow from it can be incredibly subtle. Sometimes maybe even impossible to fully measure empirically once an AI is built. How will we ever truly know? How will we measure whether our future AI systems are just getting better and better at performing understanding or if they've somehow actually achieved it?